Hey everyone, this is a video to go over how to name molecular compounds. That's going to include acids, which we're going to do here in a minute. We're going to start by covering some of the basics of non-acid molecular compound naming. We're also not going to try to name organic compounds. That's a whole other thing that we're not going to try to cover. And normally you're going to cover that in organic chemistry. So the kind of compounds we're looking at are, remember that molecular compounds contain nonmetals only. And so, for example, CO2 would fall into that category. And this is, of course, the common carbon dioxide. And another example would be CO, carbon monoxide, stuff that kills people when they uh, haven't checked their fireplaces or, try to run a generator too close to their house. But these are two good ones to start with to think about how we name these. Notice that there's more than one combination of carbon and oxygen in a compound. Molecular compounds, the atoms do not have charges, so we can't use the same charge rules that we do with uh, ionic compounds. So there's lots of combinations that are possible, and there's no way at this stage of the game to predict which ones are stable. And so we just deal with them as they come up, and we have to, because there's no charge rules, we have to name them based on how many atoms are present in the compound. So here we have a single carbon and two oxygens, so that becomes carbon dioxide, the di prefix meaning two. And in this compound, we have a carbon and an oxygen. So that's carbon monoxide, mono, standing in for one. Now, notice that neither of these compounds do we say mono out here in front. We don't say monocarbon dioxide. Anytime you have a single atom as the first atom in the molecule, we just drop the mono. Um, it's just assumed that there's only one of them. Okay. There's a whole series of these prefixes that you need to be aware of. Mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, etc. And you should just be familiar with those. So if you had a compound that was, say, S2F4, and a lot of times I use compounds, whether they're actually stable or not, I like to use them as examples. It also makes it harder to Google the answer on some of these ones that don't actually exist. But anyway, we would call this compound disulfur, and then tetrafluoride. Notice that these also end in "ide," even though there's no anion. Up until now, when we've dealt with "ide," it's been the suffix for the anion, the negatively charged ion in an ionic compound. And for historical dumb reasons, we change these to "ide" as well for the suffix. So it's just something we do. It is not meant to imply that there's a negatively charged fluoride present. It's just part of the naming structure. All right. Um, also, this allows you to go the other direction. So if I were to give you um, uh, tetroxide, sorry, tetraphosphorus, trying to use an actual one, tetraphosphorus uh, decoxide, tetraphosphorus, that would be 4. Dec, just like decade, stands for 10, so this would be O10, right? So the name is going to, the name of the compound is going to convey the actual number of atoms in the compound using these prefixes. Okay, so that's fairly straightforward for these once you know the prefixes. All right, so what do we do with acids? Acids are a whole other ballgame here. All right, so acids. Let's look at some examples to try to understand what's going on. So let's look at the series H2S, H2SO3, and H2SO4. This first one is called hydrosulfuric acid. And the second one here is sulfurous acid. And the third one is sulfuric acid. All right. So the first thing to notice here is that the only one of these that has the prefix hydro in it is the one that does not contain a polyatomic ion as its negatively charged ion. Now, we're going to come back to this at some later point, but acids are really weird because they're actually molecular compounds, except for a few. They all contain all nonmetals. Remember, hydrogen is a nonmetal, even though it's on that far left-hand side of the periodic table. It's the oddball over there. And so acids, however, are sort of kind of halfway in between a molecular and an ionic compound. We're going to see in a few days that some of them are going to dissociate in water, and all of them dissociate to at least a small degree in water, producing free hydrogen ions and free cations, anions. And so they're going to be this kind of weird halfway between an ionic and a molecular compound. Not everyone in the chemistry world agrees with my characterization of that, but that's how I think of them. And so in this case, I'm going to refer to sulfur as the anion in this acid, which again is not quite correct because it's not really an ionic compound, but I hope that you see that it's that's what I'm trying to get at. Okay, so if the anion is a monatomic ion, meaning it's just straight off the periodic table, there's no it only contains one atom. We're going to put this hydro prefix on here, and we're going to change we're going to make the suffix "ic." Right? Now, what happens if we do have a polyatomic ion, like in this case? So this polyatomic ion is the ion sulfite. Okay. Anytime the anion ends in "ite," we're going to replace "ite" with "us." All right. So we take the name of the element that is the non-oxygen part of the polyatomic ion, and we take that suffix of "ite" from the polyatomic ion and we change it to "us." So this becomes sulfurous acid. You could argue that this ought to be sulfic acid, and it's a whole thing that I don't want to get into, but if you call it sulfic acid on a quiz or exam, I will accept it. The key thing being that you change the suffix to "us." This anion here is sulfate. "Ate" suffix gets changed to "ic" instead. And so, again, we have the sulfur for the sulfur part of the anion, and then "ic" replaces that "ate" suffix. The way that I remember this is there's a little mnemonic you can use for this, which is "I ate something icky." Right? So "ate" becomes "ic," and then dynamite is dangerous. Wow, that's not, you can't write all of a sudden. Dangerous. So the key thing here being "ite" becomes "us," "ate" becomes "ic." All right. So if you were to look at another example for this, would be, for example, the two acids composed from these two very similar cases. So NO3 here is the nitrate ion. We're going to change "ate" to "ic." So this is going to be nitric acid. Whereas the NO2 minus ion is the nitrite ion. "Ite" is going to become "us." So this is nitrous acid. Notice that neither one of these has a hydro in front because it doesn't contain just a nitrogen. It contains these polyatomic ions as part of the acid compound. All right. Acid naming is a little tricky. Everyone wants to put the hydro on everything. Everyone is still at this stage of the semester struggling to remember all the polyatomic ions, which is fine. You'll get the hang of it. We're going to work extensively on this But I hope this has been a good review to get you started. Thanks.